All right, welcome to The Explainer, folks. I am absolutely pumped you're here today because we are going to fundamentally break down and probably shatter everything you think you know about reality. We're tackling a concept that is so completely hardwired into our daily lives that honestly, we almost never stop to actually look at it. But today we're going all in. We're going to unpack the mechanics, the physics, and even the biology of something completely invisible yet completely inescapable. So let's just dive right into this.
I want to start things off by asking you a deceptively simple question. What time is it? Normally, we don't even think about it, right? We just glance at our wrists or pull out our phones. We treat time like it's just a set of numbers, this rigid cosmic clock just ticking away in the background, telling us when to wake up, when to work, when to go to sleep. But what if I told you that every day ticking clock is a total illusion? Seriously. Today, we're going to completely tear down that illusion and look at what time actually is. And trust me, the reality is way more mind-bending than anything you've ever imagined.
You know, that simple question, what time is it, perfectly captures where all our modern confusion started. For the longest time, we just took Isaac Newton's word for it. He believed in absolute time, basically picturing the universe as this steady cosmic metronome that just ticks away at the exact same pace no matter what's going on. But then, along comes Albert Einstein with his theory of relational time. Einstein basically said, no, wait, time is actually created by relationships and changes. And the crazy part? We know for a fact Einstein was right. Just look at the impossibly precise aluminum ion clocks in Boulder, Colorado. Scientists took two of these perfectly synchronized clocks, and all they did was move one of them 12 inches higher, just 1 foot. And guess what? That higher clock actually beat a tiny bit faster, just because it was slightly further away from Earth's gravitational pull. Gravity literally, physically slows down time.
Section 1. The illusion of now. Is time in our heads?
Okay, so now that we know the cosmic metronome is a total myth, it turns out the mystery of time isn't just floating out there in deep space. It's actively being constructed right inside our own heads. Let's do a quick experiment. Snap your fingers. It feels totally instantaneous, right? You see the snap and you hear it at the exact same moment. But here's the catch. Sound info hits your auditory system and processes super fast, while visual info moves a lot slower through your visual system. Those signals are arriving at your brain at entirely different times. Your brain is basically acting like a video editor. It grabs that fast audio track, holds onto it, waits for the slower video track to catch up, and then stitches them together to serve you up this neat little fake story of now. And because of that tiny processing delay, just a few millionths of a second, every single one of us is actually walking around living slightly in the past. No way, right?
And what's incredibly fascinating is just how flexible our personal timelines really are. Our biological and psychological states can completely warp how we experience time. Take something like smoking marijuana, for instance. It can make time feel like it's dragging on endlessly, simply because the brain loses its ability to nail down memory landmarks. On the flip side, think about a terrifying moment, like a car accident. People constantly report experiencing a slow-motion replay. That's your brain's emergency center kicking into overdrive, laying down insanely dense memories so you can survive. But when this internal clock really breaks down, it gets tough. In schizophrenia, patients can actually experience this profound disconnect between their actions and sensory feedback. The brain fails to adjust to those processing delays we just talked about, making them feel like they didn't actually cause their own actions. Time is just so deeply, profoundly personal.
Section 2. Inside the block universe. Time as a dimension.
So, if our everyday sense of time is basically just a biological hack, what is the actual physical reality? Well, to wrap our heads around that, we have to accept a massive paradigm shift based on the constant speed of light. And it brings us to this absolutely staggering quote from Einstein. He said, "The distinction between the past, present, and future is only a stubbornly persistent illusion." Einstein realized that time is just a dimension. It's exactly like the 3 dimensions of space we walk through every single day. Space and time are quite literally woven together into a 4-dimensional fabric we call spacetime. All right, so here is the crucial concept physicists call the block universe. I want you to picture all of spacetime as this giant, solid block of cake, where the past, the present, and the future all exist simultaneously. The whole shebang is just there. We each experience the universe as our own unique slice of this cake, and that slice represents our personal now. But here's where it gets wild. Because light takes time to travel, everyone's angle of that slice is slightly different. Say you look up at the star Alpha Centauri. The light hitting your eye took over 4 years to get here. So your right now on Earth actually includes 4-year-old past events from Alpha Centauri. There is literally no single universal now anywhere in the cosmos. Which naturally leads to this mind-bending thought experiment.
What if you actually could experience the past, present, and future all at once? The physicist Jim Hartle came up with this great metaphor using a game of roller hockey. Imagine a player slapped on a pair of futuristic goggles that force them to see multiple delayed nows simultaneously. If they saw everything at the exact same time, they'd be totally paralyzed by the sheer overwhelming universe of choices. I mean, they would literally never catch the puck. The fact that we have this strict, linear past-to-future perception, that's really just a brilliant evolutionary survival trick. Our brains compute time this way just because it's the most efficient way to keep us alive.
Section 3. The birth of time. When did the ticking actually start?
Now, if time is a dimension baked into this giant block universe, we kind of have to ask, when did this cosmic clock actually start? There's this super fascinating theory by the physicist Larry Shulman. So we all know the Big Bang happened around 13.8 billion years ago. But for the first 380,000 years after that, the universe was basically just a dense, insanely hot cloud of plasma. Photons, particles of light, couldn't move freely at all. They just kept smashing into loose electrons and protons. And since time is essentially a measure of change, and we measure change using light, Shulman argues that during this early period, time literally did not exist. It wasn't until a process called recombination, when the universe finally cooled down enough for atoms to form, that light could shoot across space. That exact moment, that's when the universe's clock finally started ticking. Amazingly, we're still trying to prove the fundamental mechanics of time right now. Over at UC Berkeley, there's this incredible project called the time ring experiment. Scientists are taking calcium ions, arranging them into a microscopic ring, and chilling them down to a billionth of a degree above absolute zero. At that state, their absolute minimum energy level, they physically shouldn't move, period. But quantum mechanics suggests that space has these tiny underlying fluctuations, or jitters. If this completely frozen ring of ions somehow starts spontaneously rotating, it's going to prove that time itself, just like space, is fuzzy and literally fluctuates at a quantum level. Incredible.
Section 4. The time travel reality. Moving forward and back.
Let's pivot to a fan-favorite topic here, time travel. The truth is, technically, every single one of us is already a time traveler, right? We're all relentlessly moving forward. But can we control it? Well, traveling forward into the future is 100% proven science. Remember how gravity and speed slow down time? Take cosmonaut Sergei Kriklev. He spent over 800 days in orbit, whipping around the Earth at 17,000 miles per hour. Because he was going so ridiculously fast and was slightly outside Earth's strongest gravity, he actually aged slower than the rest of us. He essentially time traveled a 48th of a second into the future. We literally see this happening every day at the Large Hadron Collider, too. Forward travel, that's just an engineering problem. But backward travel, well, that requires physics that seem completely impossible. Let's rapidly break down why hitting reverse is so impossibly hard. What about theoretical infinite rotating cylinders? Yeah, trying to actually build one of those would just rip a hole straight through space-time. Okay, what about black holes? Definitely not time machines. The singularity inside would just instantly crush you. How about wormholes? Physicist Kip Thorne describes them like a worm drilling a shortcut through an apple. Sounds great, but to keep a wormhole propped open, you'd need massive amounts of anti-gravitational negative energy. That would require godlike technology completely beyond human comprehension. Honestly, the only tiny glimmer of backward influence we've ever seen is something called the quantum pigeonhole principle by Sandu Popesco, which hints that the future might influence the past, but we're strictly talking about subatomic, microscopic particles here, not DeLoreans.
So, does that mean visiting the past is totally off the table? Well, not necessarily. Our absolute best, and maybe only, shot at visiting history might actually rely on extreme, far-future computers. As our processing power keeps evolving exponentially, future civilizations might be able to build digital simulations of the past that are so incredibly massive and complex, they are quite literally indistinguishable from reality. So if you want to visit the past, ironically, we might just have to wait for the distant future. Section 5. The limits of eternity. Can time end? You know, in Western culture, we pretty much just accept the assumption that time is this straight line rocketing forward towards some dramatic cosmic finale. But a linear timeline,
that's actually just a cultural invention. It is not a fundamental law of human thought. Look at the Amendawa tribe down in the Brazilian Amazon. They don't use calendars. They don't use clocks. They don't even have an abstract word for the concept of time or this idea of looking back at their childhood. When researchers asked them to visually map out events using paper plates, they didn't line them up straight or make a circle. They just grouped them by the natural flow of the seasons, like when it's time to plant or when the rivers flood. It is just such an incredibly grounded, entirely different way of organizing reality. Yet in our modern tech-driven culture, we have this desperate need to map out the entire universe's timeline and predict exactly how it's all going to end. Theoretical physicist Tom Banks actually tried to calculate exactly how much data we would need to capture the full history of what he calls the universe's causal diamond, basically the absolute limits of what we could ever possibly measure from the beginning of time to the end. Just picture this absolutely staggering number, 10 to the power of 10 to the 123. That's a 1 followed by 10 to the 123 zeros. If you literally sat down and wrote 1 0 every single second for the entire history of the universe, you wouldn't even come close to finishing it.
And here is the truly, deeply humbling part. There's a second, much smaller number, 10 to the power of 10 to the 90. That number represents the absolute maximum amount of data we could ever physically collect. Why? Because if we ever tried to build equipment large enough to hold all that information to reach that first, bigger number, we would cram so much physical mass into one area of space that the universe would literally just collapse into a black hole. Think about that. The fundamental laws of physics outright ban us from knowing everything. Which brings us to our final, incredibly provocative thought for today. If the universe physically holds vastly more secrets than we can ever possibly measure, and if predicting the ultimate fate of eternity is mathematically futile, isn't it enough to simply live for the now? Time is just so deeply mysterious. Whether it's a clever illusion whipped up by our brains, a rigid block where the past and future already sit there waiting, or just a quantum jitter of microscopic ions, what remains undeniably true is the beauty of our human experience. We each get our own fleeting, remarkably unique slice of this block universe. And honestly, making the absolute most of that slice, right here and right now, well, that might just be the greatest scientific and personal achievement of all.